Hey there, welcome to Ontario Math, and we're going to kick right into an intro to algebra. Why do we need to know algebra, or do we want to learn to know how to about algebra? Well, learning the idea and basic steps will help solve problems. You'll actually use algebra later to solve problems and tough equations. You're going to be learning about algebra for most of your elementary and high school life, so it's important to kind of really get the idea and basics down now so you can use it and apply it later on. So let's kick right into it. I have a few different definitions here to help you understand the basics of algebra. So the first one is a constant. Okay, so all a constant is, it's a fancy word, but it's just another word for a number that has a value that doesn't change. So, for example, we'll just give a constant of 47, right? So if that's in an algebraic expression or an equation, 47 is 47. It's not going to change. 47 just doesn't magically change into another number. It's always going to be 47. So if you're talking about 47 jelly beans, then you're always going to have 47 here, unless we do something to it later, and it might, the answer might change, but you have 47 jelly beans to start off with. It could be anything. It could be 13, it could be 12. Choose a number. A constant is the value itself. Okay, it won't change. A variable, on the other hand, is a number that we don't know yet, and it is usually represented by a letter. It's like a mystery. We don't know it. It could be anything. We usually, for some reason, use the letters X and Y in algebra. But it could be, any letter you want, B or M. But the idea is this is a mystery number. We don't know it. So X could mean 101. X could represent 32, 1, or 2 million. It's a mystery and we don't know it. And we can solve it later when we get into algebraic expressions and equations. But we don't know it right now. An expression, on the other hand, is a group of numbers and operations and can include variables. So, for example, a basic expression is like 3 plus 4. So here are your constants, 3 and 4, right? And there's an operation, right? So 3 plus 4, or 10 subtract 2, okay? It can include variables, so you can have maybe b plus 2. Again, we don't know what b is. B can be 10, right? B can be 11, b can be 1. But b plus 2 is an expression, or, I don't know, you could have 12 subtract c, right? So I'm just adding numbers and variables and operation signs. You could do multiply and divide as well, but that's an expression. No equal sign, but just that part in itself. The equation is like a balance or scale, okay? So I'll just kind of throw in this picture of a balance here, and I like to think of the idea of a balance and scale because both amounts on each side, they must be equal, okay? They have to be equal. So like a balance, a proper balance, this side can't weigh more than that side, and so it can't tip either way. So one of the basic things we can talk about is, well, here's a basic one here. 3 equals 3. Well, that just makes sense to us, right? 3 is equal to 3. We could also think about the idea as 2 plus 1 equals 3, right? This still balances, 3 on this side, 3 on that side. We could also think of it as something like this. We can add an expression, an algebraic expression on one side, and this will turn into an equation, okay? Because we can solve for the letter. So take a look. If I do 12 subtract x equals 10 this time, we can solve for x. We can figure out what x is here in this case. Okay, and here's where we'll do a little bit of work. So 12 subtracts something, an unknown right now, but we can figure it out because we have the other side of the scale, which is 10. So 12, you can figure this out with me, subtract what equals 10? 12 subtract 2 equals 10, right? So if you do 12 subtract 2, that turns into 10. 10 equals 10, and it balances out. So we can solve for x there. So what did x turn into, did we say? X turned into 2. So x equals 2. First step in algebra. We'll talk more next